Back in 1945, something totally new appeared in our sky. It was this cloud, a terrifying mushroom cloud, that shot 18 kilometers straight up, and it was a signal that humanity had finally unlocked the insane, destructive power of the atom. So today, we're going to break down the science, the story, and the staggering consequences of the atomic bomb.
To really get what a huge shift this was, you have to understand the scale. We're not just talking about a bigger bomb. No way. We're talking about a weapon that was on a completely different level of reality. It jumped in destructive force so massive, it's honestly hard to even wrap your head around.
Okay, let's really dive into this. To get a feel for what the atomic bomb actually meant, we need to compare it to what came before. Because the most fearsome, the most powerful weapons of World War II, well, they were about to become completely obsolete, practically overnight.
I mean, the sheer jump in power is just astounding. Think about it. The absolute biggest, baddest conventional bomb during the war was the blockbuster bomb. It packed 11 tons of TNT. But the first atomic bomb? It wasn't just a little bigger. It exploded with the force of 22,000 tons of TNT from a single bomb. It was like a force of nature, completely unleashed by human hands.
So how in the world was this incredible energy released? Well, the answer isn't in chemistry, like it is with TNT. No, it's way deeper than that. It's deep inside the core of the atom itself. And this is where we get into the fundamental physics that literally changed the world.
Okay, so the key concept here is something called nuclear fission. Just imagine the nucleus of a really heavy, kind of unstable atom, like uranium. If you can fire a teeny tiny particle, a neutron, at it in just the right way, that nucleus splits apart. And when it splits, whoosh, it releases a tremendous amount of energy. But that's not the only thing it releases. So how does splitting one tiny little atom lead to this massive explosion? It is all about the chain reaction. It starts with one neutron splitting one atom. Now, that split releases energy, sure, but it also releases more neutrons. Those new neutrons then fly out and split more atoms, which then release even more neutrons. You see where this is going, right? It's this incredible cascade, like a microscopic snowball effect, that grows exponentially in a fraction of a second, and the result is an unimaginable burst of energy.
Now here's the catch. This crazy chain reaction can't happen with just a few atoms scattered around. You need to have enough of the material, a sufficient amount of it, packed together really densely. It's a threshold, and that threshold is known as critical mass. And once you hit that point, the reaction can sustain itself, and that's when you get the explosion.
This incredible, world-changing scientific leap didn't just happen in a lab somewhere by accident. Nope. It was driven by a top-secret, high-stakes project, and it was led by one of the most brilliant and, frankly, complex figures of the entire 20th century.
And that figure, well, that was J. Robert Oppenheimer. He was this genius theoretical physicist who had a profound understanding of the quantum world. He was the one chosen to lead the Manhattan Project. Can you imagine that job? To assemble a team of the world's greatest scientists and turn this abstract, mind-bending theory of nuclear fission into a real, functional weapon?
So all of this work, all of this science, all of this secrecy, it all culminated in a single moment. A moment that would forever draw a line in human history. The very first time this terrifying new power was unleashed, not in a textbook, but in the real world. So picture this. It's the New Mexico desert, July 1945. It's codenamed the Trinity Test. And there, in the pre-dawn darkness, the world's very first atomic device was detonated. For a single, blinding moment, it looked as if the sun had decided to rise in the completely wrong place. As he watched this terrifyingly beautiful fireball just expand and climb into the sky, Oppenheimer famously recalled a line from the Hindu scripture, the Bhagavad Gita. He later said he thought of the line, "Now I am become death, the destroyer of worlds." What a chilling, powerful way to acknowledge the force his team had just brought into existence. But he remembered another line from that same text, one that really captures the sheer, overwhelming awe of that moment. This wasn't just destruction he was witnessing. It was a spectacle of cosmic power, a light brighter than anything anyone had ever seen on Earth. And those two quotes together, they just perfectly capture the terrible, awe-inspiring duality of the atomic age.
But believe it or not, the atomic bomb was not the final word. The science of fission had unlocked one door, but right behind it was another, and this one led to a weapon that would make those first atom bombs look small.
Okay, so the atomic bomb, that was a fission device. It worked by splitting heavy atoms apart. But the next generation weapon, the hydrogen bomb, was a fusion device. Instead of splitting atoms, it smashes light ones, like hydrogen, together. It's literally the same process that powers our sun. And get this, a fusion reaction needs so much heat and pressure to even start that you need a smaller fission bomb, an atomic bomb, just to act as its trigger. The power leap is just staggering. We go from thousands of tons of TNT to millions of tons. And all of this happened so fast. Just 5 years after the first atomic bombs were used in war, President Truman gives the order for a super bomb project. The US successfully tests one, and then just 2 years later, the Soviet Union has their own. Just like that, the Cold War arms race was truly on, and both sides now had weapons of absolutely apocalyptic power. Looking at it like this, the escalation is almost impossible to really comprehend. You've got the blockbuster bomb with its 11 tons of TNT. Then the first atomic bomb at 22,000 tons. That jump is already massive, but then you get to an early hydrogen bomb, and the power is measured in the millions of tons. The scale of destructive capability just grew exponentially, to the point where this chart can barely even contain it. This is the terrifying growth of destruction that came to define the 20th century. Which of course brings us to a final, very sobering question. The work of Oppenheimer and the Manhattan Project was an unbelievable triumph of human intellect, of scientific discovery. But in solving one of nature's greatest puzzles, did we inadvertently start a countdown to our own end? That's the question that has been haunting the world ever since.